To meet the objectives of more renewable energy sources, to meet the target of slashing CO2 in generating energy, a new approach in managing and controlling our production and distribution systems is absolutely essential. Not only just management and control, the thermal generation fleet has to be changed, in part, as flexibility and speed is more needed and more valuable. And it must be affordable, reliable, sustainable. The power systems in use today do what they were created to do: provide energy for our economies, for our societies. But when we seek to decarbonize and reduce CO2 generation, the system is faced by new challenges. Can it pass the test? Solar output varies and wind conditions continuously change. Existing generation capacity is largely based on steam power plants, which cannot start and stop quickly to respond to these rapid and continuous changes. The more renewables that are added, the greater the strain. Starts and stops, loads fluctuating up and down. The rest of the system must be able to mirror the wind and the sun. Since the system was not designed to manage such variations, the benefits of wind and solar cannot be realized. In order to be able to balance wind power when the wind falls, traditional thermal power plants must be kept running, still pumping out CO2. And the ambitious target set for CO2 reduction will not be met. Because of the slowness of the rest of the system, power, free of charge, free of carbon, cannot be utilized to the full. When extensive renewables are being exploited and the wind suddenly stops blowing, conventional plants just can't start and ramp up again fast enough. Suddenly, supply cannot meet demand. To balance supply with demand and include renewables, flexible and dynamic power generation capacity needs to be added to the system. Dynamic, fast starts and stops. Nearly instant loading and load balancing allows slower power plants to operate optimally. Renewables are fully utilized, always used first when available, never wasted. Gas is the fuel that can enable a sustainable low-carbon power system. Natural gas and biogas are excellent fuels for smart power generation. Gas is abundant. Gas enables construction of adequate low-carbon flexibility. This is not theory, this is fact. Smart power generation is already being used to balance loads, to enable CO2 reduction, to make renewables truly viable. Smart power generation is proven. The transition to a sustainable, reliable, and affordable energy infrastructure requires smart power generation. It's efficient and flexible. The power system can finally become affordable, reliable, and sustainable.